Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm here with Jon Herlocker of Tignis. We're going to talk today about Agentic AI. This is part of an ongoing series about using AI in semiconductor manufacturing. Jon, what is Agentic AI and how does it differ from generative AI and all the other AI types that would come before it?
Yeah, thanks, Ed. I think just a little personal story about agentic AI. Large language models and Chat GPT kind of changed our world in some way, right? In terms of the ability to get answers to questions incredibly fast from a massively large database, seemingly human-like interaction, etc. Very powerful, right? But there's still a certain amount of manual iteration. I have to think about the right prompts I'm going to give my agent, and then it gives me an answer, and then I have to decide what I'm going to do about that answer. Am I going to query it again for another prompt, or am I going to take some action on that? And the way this happened, for example, with programming, writing code, is that I would say, hey, I would like to have a program that does this. It would generate code. I then have to take that code, paste it into my development environment, run it, test it, etc. You often got the answer, like, God, why doesn't it just do this for me, right? Like, why doesn't it just go take that code and put it in developer and run it for me, etc. And then notice it doesn't work. And then, what if I could just be taken out of the whole cycle, right? And that was really kind of where agentic AI comes in, right? And so what do you mean by agentic? Agentic means, okay, so you've got something like a large language model, right? But we're giving it like a goal, right? So rather than sort of repeatedly prompting it, here's a prompt, here's a prompt, here's a prompt, we're just giving an overarching goal. Go get this done, right? And then what we're doing is we're giving it tools, right? As we like to say, we're letting it actually do stuff, right? In the code programming case, we're letting it actually put code into the editor and run a compiler and run that thing, etc. But you can imagine that it might allow it to control a tool, or you might allow it to order equipment, or you just might allow it to do research, which is really kind of where things are, right? So this in the software development space, this is the game changer, because I could just go say, I want a program that does X, right? And then it will keep trying. It will do it. If it doesn't work, it'll fix it. It will debug itself, etc. This is really the dream of autonomy, right? Agentic is really bringing this dream of this.
So where do you go with this? What can actually be done?
My specialty is really process control on the manufacturing side. And so like this is a question that I ask myself a lot, is what does I can kind of see there's lots of places that large language models can be beneficial, but where does this agentic dream lead us, this agentic vision? And so I'm going to talk a bit about where I see it going, right? But this is not something that's happened yet, we should be clear, right? So, one of the, there's several things that we found about agents, that agentic AI, that really change the game. One is that giving them tools allows them to iterate so much faster than if we're in the loop, right? And that's amazing. It takes us out and they can get a lot more done. Giving them higher level goals means we don't spend as much time writing prompts, right? In some sense, they're writing their own prompts as they try to figure out it. And so I think that's a benefit. But the third one is really collaboration, right? Just as humans can collaborate with each other, those agents can collaborate with each other. And this is a real big breakthrough, because we no longer need to have one sort of super agent that does everything. Instead, we can create specialized agents that are experts in their own business, right? And they can collaborate with other agents to get a job done, right? So let's look about what this looks like in a process control perspective within a manufacturing line. So here you see a manufacturing line, or an iconic depiction of a manufacturing line. Each of these is a process tool, litho, etch, etc. Imagine now that for each of these tools we have an agent, right? And the agent is an expert in controlling that tool and keeping it on its spec. And likewise, this tool has it. Now, by keeping these separate, we can evolve them independently, right? And this one can get better without this one having to kind of be changed. So we can kind of limit the scope of changes as we evolve things. We can also make the height, we can really customize the training data for them, right?
The challenge here is that you have to conflate all this data, right? It all has to work together somehow.
That's right. And so this sort of comes to the root of my hypothesis. So How do we do this today with humans? Well, we have collaboration. We have, a tool owner who's responsible for this tool, and a tool owner, but these have to work together. So what do? We have an integration engineer, right? An integration engineer's job is to make sure that, these three process steps in the module all work together to deliver a device that seems to work, right? And so, but it's important but he's not, that he or she is not an expert necessarily in this tool, but this person is, right? And so I think my hypothesis is we're going to see the same sort of organizational structure evolve among agents that we have in humans, right? You're going to have this tool is like hyper trained to be an expert in this. This is hyper trained to be an expert in this. And this agent is hyper trained to get these three agents to work together, right? And I think it just keeps going, right? You've got someone who's responsible, there's an agent responsible for yield and an agent responsible for quality and this kind of stuff.
You start building up silos though by doing that as well. How do you break through those silos with agentic AI?
We've kind of learned that silos are bad, but there's reasons silos exist, right? They exist for modularity, right? They exist so that you can have independent evolution. They exist so that you can have specialization, right? So I think there are good and bads, and so in some sense, you have agents whose job it is to break the silos, and you have agents whose job it is just be good within their silos. It's really the same strategy that we use with humans. Let me give you an interesting example of silos, right? So today you have process tools that are operated by an IDM or a foundry, and then you have the OEM that provides these guys, right? Now today these guys are always in a tussle about data, right? Because the foundry doesn't necessarily want to leak its yield and process data here, and these guys also see process control as IP of them, so they don't want to really share data here. But guess what? Like you have the equipment owner here. When there's a problem, the equipment owner here calls the field service engineer and says, hey, we need to diagnose this problem. You don't have to tell me how your tool works, but you got to help me fix this problem, right? I see the same thing happening from an agent to agent basis, where you have kind of the foundry agent talking to the OEM field service agent, and their interface is now text in the same way that humans have text. And likewise, this agent can be sort of trained to not reveal secret stuff, right? And this agent can be trained to not reveal secret stuff, but together they can collaborate on solving the problem of the day, right? You can imagine that, this agent can collect a whole bunch of data from all the data systems, right? And it can pass, sanitized summaries of that over to here and so on. So I think this actually might help solve one of our challenges we have today, which is how to sort of best collaborate in a space where nobody wants to reveal the innards of what they're doing.
And these systems should get better for each fab too, but they may not be interchangeable fab to fab, right?
I think that's fair. I think that obviously everyone's getting the same tool, so these OEM agents are probably relatively specific to this tool and can be usable. But yeah, so different fabs are building different products. They have different sensitivities, different quality requirements. But it wouldn't surprise me if there's some amount of standardization in the core of this, and then some level of customization, fine tuning that individual foundries do to meet theirs. In some sense, like as you move up the hierarchy, I don't know if you call it a hierarchy with agents, right? This is the opportunity for increasing customization, right? Like what are your high level requirements, and those are communicated down to these guys in terms of what in some sense the inputs to these agents, like hey, what do my target CDs need to be, right? Are the things that individual fabs will customize.
One of the questions that will always come up here is where does the engineer fit in?
Yeah,
Are they being
absolutely.
replaced or are they now working with this?
None of this works without humans to kind of monitor it and train it and all that kind of stuff. And so my view is that the agents are doing a lot of the mundane day-to-day stuff, right? Oh, process is drifting. Let me fiddle it a little bit this way. Agents are doing a lot of the pre-work of like, okay, we just had an excursion, right? Go get all the data, find the data that's most relevant, form some hypotheses that might be wrong. But at the end of the day, I expect a human's going to be the one to sit down and look at that and say, so we're taking a lot of just the manual grunt work out of this. And so, will you need less engineers in the future? Yes, I think that's probably true. But there's no way that you could do all this without having humans involved in the process.
You just won't need as many of them. So one of the issues, you think about a fab today, they have lots and lots of process engineers. You
Right.
may need a lot fewer of them, right?
I think that's fair to say. I know a lot of AI people are hesitant to say that there will be less, process engineers or less humans of any kind. But I think the reality is that economics are driving us to be competitive. That we need to find ways to do this with less process engineers. And I do believe that this will enable it, but it's not going to make those process engineers go away, right? The agents are going to be good at maintaining a steady state once it's there, but you know, the humans are going to be needed to set all that stuff up in the first place and deal with the exceptions that happen because we talked about how AI is not always right. It's predictive, right? Somebody has to kind of be the one providing the oversight to make sure that the agents aren't going off the rails, to make sure they have the right training data, and so on.
I mean, one of the things that is happening now is people are putting in very tight control loops. What is a control loop in an agentic system?
Yeah, what's a control loop on an agentic system? I think that's an open area of research right now. You know, I think first of all, what I'm putting here is a hypothesis. This is not something that's proven, right? I just want to be clear. And so it's an active research. Everyone's trying to figure this out, right? And I think we know that fabs are conservative, right? But I think we will see some people leading the way and sort of driving sort of the research and how to do this. What does it look like? I mean, in some ways, not so different than the things we do today, right? Like when we develop advanced process control, like we are asking an algorithm to take control of our system. How do we convince ourselves that it's trustworthy, right? Well, first of all, we create bounds. We say, hey, you're not allowed to go outside these bounds, right? So we limit the damage, at least in some way. And then we do lots of validation and testing, right? We've run this a certain number of iterations. We see, it's kind of like when you're creating a product, right? You go to the point until the distribution of your outcomes is within controlled perspectives. I think we're going to see that same thing happen here. But I agree. There's more, I guess, engineering that needs to happen to develop best practices for doing this in production.
Jon Herlocker, thanks for a really interesting discussion.
It's my pleasure. Happy to. AI is changing a lot, so I suspect there'll be another session we'll have to do here shortly of the next big thing that's happening.